Welcome students to online classes of mathematics for class 9th. In this video we are going to start the chapter number 2, which is the polynomials of NCERT textbook, and we'll try to cover the exercise 2.1. This is our session number 1 for this particular chapter. And myself Deepak Gautam, teacher in mathematics in Kendriya Vidyalaya Sangathan. So let's start today's session. The chapter that we are going to study today is polynomials. This chapter is divided into 6 subtopics which are listed here. Out of these 6, we will be looking at the first 2 subtopics, which are the introduction part and the polynomials in one variable in this particular video, and the remaining subtopics will be covered in the subsequent videos. Okay, so let's start with the introduction part. So the first of all, you should know what is a polynomial. A polynomial is generally an algebraic expression, okay, which you have been already studied in previous classes. So a polynomial in one variable x is an algebraic expression in the form of, simply a polynomial is in one variable is a algebraic expression which is in the form of a0 a1 x power 1, a2 x power 2, a3 x power 3, and so on till an x power n, where a0, a1, a2, a3, and so on till an are the real numbers. Real numbers means this a can be any number. It can be a natural number, whole number, integers, rational number, or irrational number, because real number include all types of number. Okay, while the power of x, that the x that we have here, the power of this x are non-negative integers, and non-negative integers are simply called whole number. That means it can be either all the positive number from 1 to positive infinity or 0. Okay, if the power of x is in fraction or in decimal, then it will not be a polynomial, because the power of x has to be a non-negative integer, or simply we can say it should be a whole number. Okay, so some example of polynomials are 4x power 4 plus 7x cube plus 5x square plus 7 minus 2. Okay, now you can see these 4, 7, 5, here 1, and these 2 are the a's. Okay, a1, a2, a3, a4, while this x4, x3, x1, x, and here also we have x0, and x0 is equals to 1. Okay, and this 1 into 2 will be 2, so we'll don't represent this part. Okay, so write simply it as 0. All these are the variable term having power a non-negative integer, or you can say whole numbers. Okay, so this is the example of a polynomial. This is another example, x cube minus x square plus x plus 7. Okay, so moving ahead, now we have polynomial in one variable. So before that, we should understand few terminology which we have related to this chapter. First one is terms. In the polynomial with let's say x square plus 2x, the expression x square and 2x are called the terms. Okay, terms are simply the components of the any algebraic expression or polynomial. So all the components of an algebraic expression or the polynomial are called its term. Like in this case, we have two terms, x square and 2x, and each one is called the term of this polynomial. Okay, next we have coefficient. The coefficient of a polynomial is a constant number multiplied to a variable. So whatever number multiplied to a variable is called the coefficient of that variable. For example, in this polynomial x square minus 7x plus 2, the number multiplied to x square is 1. So the coefficient of x square is plus 1. The number multiplied to this x is minus 7. So the coefficient of x is minus 7. While plus 2 is the coefficient of x square. Why? As like I said, this x this 2 is not alone. We have a variable here also, which is x equals to x power 0. Okay, so this is should be written like this, but x, we know that any number having power 0 is equals to 1, and this 1 multiplied to 2 is will again give us 2, so we'll write only 2 here. But there is a variable also, which is x0. Okay, so plus 2 is the coefficient of x0. I hope it's clear to you now. So terms are the component of the polynomial, while coefficient is the number that is multiplied to a variable. Okay, then we have constant polynomial. Constant polynomial is the constant numbers like 2, 5, 7, or any other number like 9, 13, 100, 1000 are called the constant polynomial, because their value will remain unchanged, so they are called constant polynomial. Then we have zero polynomial. The constant polynomial 0 is called the zero polynomial. 0 is also called a constant polynomial, but since it's also called constant, this constant polynomial is also called zero polynomial. Okay, 0 is also called constant polynomial, but it's separately called known as a zero polynomial. Okay, then we have types of polynomial. Polynomials are categorized on the basis of two things. First is the based on the number of terms, and second is the based on the number of degree of polynomial. First is the number of term, and second is the degree of polynomials. Okay, so next we'll study about the category of the polynomials. So first is the types of polynomial based on the number of terms. Based on the number of terms, there are first is the monomial. This first word mono means one. So the polynomial having only one term are called monomials. The polynomial having only one term are called monomials, like 2x, x, 5x square and minus y cube. All these polynomials have only one term, so they are called monomials. Next we have binomials. So in this bi means 2. Therefore the polynomials having only two terms are called binomials, like x plus 1, x square minus x, y cube plus 3. All these polynomial have two terms. Okay, and the polynomial having two terms are called binomials. Okay, next we have trinomials. Similarly, this word tri means 3. So the polynomial having only 3 terms are called trinomials. For example, x square plus x plus 2, u cube plus u square minus 5. These polynomials have 3 terms, so they are called trinomials. Okay, then we have types of polynomial based on the degree of polynomials. So before understanding the types of polynomial based on degree of polynomial, we should first know what is degree of polynomial. Okay, so degree of a polynomial is the highest power of the variable. The highest power of the variable in a polynomial is called the degree of polynomial. So whatever polynomial you have, we will look at the power of the variable. Whatever the highest power of the variable, it will be called the degree of that polynomial. For example, we have this 3y power 7 minus 4y cube plus y square plus 6. In this, you can see the power here is 2, 3 and 7. The highest number here is 7. So in this polynomial, the highest power of variable y is 7. So the degree of this polynomial is 7. Like I said, we'll look at the high powers of the variable. Whatever the highest power, that will be the degree of polynomial. Like in this example, the highest power of y is 7, so degree of this polynomial is 7. If we have a polynomial like this, x power 99 plus x power 100 plus x power 105. So now you can see, as the highest power of variable x here is 105, so its degree will be 105. Okay, we'll always look at the power of the variable. Whatever the highest power, that will be the degree of that polynomial. Okay, now based on the degree of polynomial, there is first type polynomial, which is linear polynomial. A polynomial with degree 1 is called linear polynomial. That means in all the polynomial in which the highest power of variable is 1 are called linear polynomial. Okay, the polynomial with degree 1 are called linear polynomial. For example, 4x plus 5, the power of x here is 1. 2y, again the power of y is 1, and u minus 3, again the power of u is 1. So all the polynomial in which the power of variable is 1 are called linear polynomials. Okay, next we have quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. If the highest power of variable is 2, that polynomial will be called quadratic polynomial. For example, 2x squared plus 5, 5x squared plus 3x minus 5, and x squared. In all of these, the highest power of variable x is 2, 2 and 2. So this will be termed as quadratic polynomial. That means if the degree of polynomial is 2, degree of polynomial means the highest power of variable should be 2, then it will be called quadratic polynomial. Next we have cubic polynomial. A polynomial of degree 3 is called cubic polynomial. Okay, a polynomial of degree 3 is called cubic polynomial. For example, 4x cube, 2x cube plus 1, and 6x cube minus 6. So in all these, the highest power of variable x is 3. So the degree of this polynomial is 3, and it will be called cubic polynomial. Okay, the few things that you should keep in mind are that the all constant numbers are called zero polynomial. So all the constant numbers like 2, 5, 7, 100, 110 and so on, all these numbers or the constant number are called zero polynomial. Okay, the degree of zero polynomial is not defined. The degree of zero polynomial is not defined, because what is zero polynomial? Zero is called the zero polynomial. Okay, zero is called the zero polynomial. So if you have a zero polynomial, its degree is not defined. Okay, next we have the degree of non-zero constant polynomial is 0. If you have a non-zero constant polynomial, like say this 3, and we have a variable multiplied 2 is which with power 0, so the highest power variable here is 0. That's why the degree of this polynomial is 0. Okay, similarly if you have 5 and we have a variable multiplied to it with a power 0. Okay, so the degree of this polynomial is 0. Okay, that's the introduction part of this chapter. Based on all this concept, we have exercise 2.1. So now let's start the exercise 2.1. So this is chapter number 2, polynomial. We're going to start the exercise 2.1. First question here is, which of the following expressions are polynomial in one variable and which are not? State region for your answer. You have to identify out of these polynomial which is the polynomial in one variable. Okay, you have to identify which is the polynomial in one variable and which are not, and you have to give the region for your answer. Okay, the first that we have is, this is answer number 1, part 1. The first that we have is 4x square minus 3x plus 7. Okay, the question is whether it's a polynomial in one variable. So there is only one variable involved, which is x here and x here. So that means, and the power of x is a non-negative integer, so which is 2 and 1 here. So it is a polynomial in one variable x. Okay, That's the answer. Second one is y square plus root 2. So you are asked whether it is a polynomial in one variable. The variable that we have here is only y. So there is only one variable and whose power is 2, which is a non-zero integer, or you can say whole number. So it is also a polynomial in one variable y. So right, it is a polynomial in one variable y. Okay, that's how you have to write the answers. Third one, we have 3 root t plus t multiplied to root 2. Again same question, whether it is a polynomial in one variable. Answer for this one is, if you write this in simpler form, it will be 3 and the root 2 will be, that means its power is 1 by 2 plus t root 2. Now you can see, as the power of t here is 1 by 2, which is a fraction number, or it's a rational number but not a whole number. So answer for this one is, it is not a polynomial because power of t is not a whole number. Okay, because the power of t here is not a whole number, it's a rational number 1 by 2. That's why it's not a polynomial. Next one, part 4, we have y plus 2 by y. We have y plus 2 by y. Okay, again same question, you have to identify whether it's a polynomial or not. Many of you may think that it's a polynomial, but it's not a polynomial. Why? You may see that there is only one variable y and the power of y is 1. Then it should be a polynomial. Why it's not a polynomial? Because we can write this as y plus, we have 2 here, and when you shift this y in the numerator, it will be y power minus 1. Okay, so this 2 by y can be written as y power minus 1. So that means minus 1 is not a whole number. So again the same reason, it's not a polynomial because the power of y is not a whole number. Okay, it is not a polynomial because power of y is not a whole number. Okay, that's why it's not a polynomial. And the last one, we have x10 y3 and t50. We have x10 plus y3 plus t50. So as you are asked, is it a polynomial in one variable? Do we have only single variable here? Answer is no, because the number of variable here are 3. We have 3 variable, one is x, other is y, and next is t. Though it is a polynomial but not in a one variable. it is a polynomial in how many variables? 3 variables. So it's a polynomial but in 3 variables. Okay, so the answer one is for one, this one is first two are the polynomial, third and fourth are not polynomial, and fifth is a polynomial but not in 1 variable. It's a polynomial in 3 variables. Okay, moving ahead, we have question number 2, which is write the coefficient of x square in each of the following. So you have to write the coefficient of the x square in each of the following polynomial. The first one that we have is 2 plus x square plus x. Coefficient means the number multiplied to a variable. So you are here, but you are asked the particularly coefficient of x square. Okay, here the coefficient of x square is plus 1. Okay, the number here is plus 1. Next we have 2 minus x square plus x cube. You are asked the coefficient of x square, so write the coefficient of x square is minus 1. The number multiplied to here is minus 1. Third one, we have pi by 2 x square plus x. Now the coefficient of this x here is x square. The coefficient of x square is, the number multiplied to x square here is pi by 2. Okay, so the coefficient of x square here is pi by 2. Next and the last one for is root 2x minus 1. And here you are again asked the coefficient of x square. Do we have x square term here? Answer is no. So how can we write the coefficient of x square? Now you can see this term can be written as 0 multiplied to x square plus root 2x and minus 1. Okay, here you can see 0 multiplied to any number will result into 0, so this term will be eliminated. So we remain only this part which is given here in this question, though there was a term with x square and the coefficient of x here is 0. So answer is the coefficient of x square is 0. Okay, these are our answer. The coefficient of x in first one is plus 1, minus 1, pi by 2 and 0. These are our answer. Moving ahead, we have question number 3. Question is, give one example each of a binomial of degree 35. We have to give an example of binomial with degree 35 and a monomial with degree 100. So you can write any polynomial and write the power of variable 35 and 100. For example, okay, first you're asked binomial, so write any binomial. Let's say x plus 1. It's a binomial because it has two terms and we want its degree to be 35, so just write the power of x as 35. That will be the example. You can write many more such examples. Like say we can write like x plus 3x. Okay, as you are asked, now it's a binomial because it has a two terms and its degree should be 35. So write the power 35 here. Okay, so it's another example. Okay, you can write many more such example. Next you are asked a monomial with degree 100. So this one is also simple. Just write any symbol, let's say t, and write its power 100, or it can be 0 power 100, it can be a power 100, and many more. Okay, you can write as many as examples you want to write. Just write down any variable and give its power 100. Okay, there can be many more such examples. What you are asked, one example of each. Okay, you can write either these which I have written here, or you can write some other example by yourself. Okay, I would suggest that you should write some more example by yourself. Okay, moving ahead, we have the question number 4, which is the write the degree of each of the following polynomials. You have to write the degree of polynomials. Like I said, the degree of polynomial is the highest power of variable. So first that we have is 5x cube plus 4x square plus 7x. Now the variable that here we have is x, and the power of x here is 1, here the power of x is 2, and here the power of x is 3. That means the power of degree of this variable is 3. So its polynomial is 3, right? As the highest power of variable x is 3, therefore degree of this polynomial is 3. Okay, next one is y minus 4 minus y square. Again there is only one variable which is y, and the highest power of y here is 2. Therefore the degree of this variable is this polynomial is 2. So write again, as the highest power of variable y is 2, as the highest power of variable y is 2, therefore the degree of this polynomial is 2. Therefore the degree of this polynomial is 2. Next we have part 3, which is t5 let me extend this. Okay, we have 5t minus root 7. Okay, now as you can see, the highest power of variable t here is 1, so its degree will be 1. So you will write its answer in the comma statement like I have written it here. Its degree will be 1. Okay, you have to write the answer like I have written it above, which is the highest power of variable t is 1, therefore the degree of polynomial is 1. And the last one we have 3. Like I said, the degree of all the constant polynomial is 0, so its answer is 0. Degree of all the constant polynomial is 0, its answer will be the degree, let me write it here, the degree of all the constant polynomial is 0. Okay, that's how you can write the degree, or you can identify the degree of any polynomials. Now moving to the last question of this exercise, which is the question number 5. Question is, classify the following as linear, quadratic and cubic polynomial. Okay, you have to identify the following polynomial as linear, quadratic and cubic polynomial. So linear is when the degree of a polynomial is 1. Quadratic is when the degree of polynomial is 2. Cubic is when the degree of polynomial is 3. Okay, so right, we classify them as linear, quadratic and cubic. The first one is x square plus x. Highest power here is 2, so it's a quadratic polynomial. So it will be written here, which is x square plus x. Second is x minus x cube. The highest power of variable here is 3, so it will be a cubic polynomial. Third, we have y plus y square plus 4. The highest power of variable here is 2, so it will be a quadratic polynomials. The last two. Fourth one, we have 1 plus x, and the power of x here is 1, so it will be a linear polynomial. One plus x, this one was second and this one was third. Okay, next we have 3t. Again the power of t is 1, so it will be a linear polynomial. Sixth, r square. So simply r square is with power 2, so its degree is 2, so it's a quadratic polynomial. And the last one is 7 cube. As you can see, the power of variable is 3, so its degree is 3, so it will be a cubic polynomial. So that's how you can categorize or classify any polynomial based on its degree as linear, quadratic or cubic polynomials. This was the answer number 5, not 3. So that's all from this exercise. We have completed all 5 questions of this exercise. So now your homework is to practice all these questions at least 2-3 times and revise whatever we have done in the introduction part. Write that in your notebook and revise that. Only then you will be able to complete the exercise. Okay, so that's all.